Today we are looking at precipitation reactions. So in particular the precipitation reaction of silver chloride in water, which we can illustrate with this animation. In this reaction, when you add sodium chloride solutions to a silver nitrate solution, an instant white precipitate forms. Okay, so to understand what's happening, let's look at the aqueous silver nitrate, a clear, colourless liquid. At the molecular level, or ionic level, the negatively charged nitrate ions occasionally collide with positively charged silver ions, here coloured blue, but the water molecules end up pulling them apart. So, when we're looking at the hydrated ions of the silver ion and nitrate ion, notice in this particular case of the silver ion that the oxygen ends of the water molecules point towards the positive silver ion. Okay, whereas in the case of the nitrate ion, which contains a nitrogen atom, here coloured dark blue, with the 3 oxygen atoms, coloured red as usual, bonded to it. Both ions are hydrated in solution. One silver nitrate solution contains about 55 water molecules for each silver ion and nitrate ion. These ions are separated from each other by, on average, about 3 water molecules. So silver nitrate solutions contain billions of hydrated silver and nitrate ions moving around amongst the water molecules. So now let us look at the sodium chloride solution. Aqueous sodium chloride is also clear and colourless, just like the silver nitrate solution. As before, the oppositely charged ions occasionally collide, but the water molecules keep them separated. Once again, notice how the water molecules are orientated differently around the sodium and chloride ions. The symbolic representation for a solution should always show the ions are usually separated from each other, as you can see with that green chloride separated from the silver, or the silver sodium. Okay, so sodium chloride solutions contain billions of hydrated sodium and chloride ions moving around and occasionally colliding. So now let's look at the molecular level. Now if we go back and see what happens when these two solutions mix, imagine we are at the surface of the silver nitrate solution just as the first drop of aqueous sodium chloride hits. Now we have a solution of 4 different types of ion. So which combination produces the white ionic solid? Well, one possibility is that when the nitrate ions collide with the sodium ions, they could form a precipitate, but we know from our solubility rules they don't. In fact, solid sodium nitrate is quite soluble in water. So the only other option is silver chloride. So the combination of silver and chloride ions form pairs which cluster together to form ion groups, which clump together or aggregate together to form a growing crystal. There is a nitrate spectator ion moving past, and you can also see other ions joining the crystal. So the next time you see a solid form in a test tube, imagine the ions combining together to form a bigger and bigger crystal that aggregates together to form a solid precipitate.